Hello YouTube! Today we're doing something different. We're doing what would be similar to a walkthrough when you purchase a new RV, in case people are buying a used RV and they don't have that opportunity. This is not an expert class, or it's not for anybody that is seasoned in RVs. This is just for somebody that might be having a little problems, and very minor introduction into the electrical system and how it works in your RV. Through this, I do not recommend anybody electrocute themselves. Nobody should be messing with parts of the electrical system that they don't need to be messing with, but it just more or less tells you what you're dealing with and why it might be the problem if you're having a problem. There will be this flow sheet that I made available in the description below. But there's basically two sides to this thing. You have the shore power and the generator are both feeding into the same transfer switch, and that's how it works. But before we get to that point, I want to explain that the shore power is just like the electric company coming in and hooking up your house. Then everything works the same way for the 115 volt systems. You'll hear that called 115, 110, 120. It's the exact same household current that you have in a sticks and bricks when you plug in your computer or you plug in the television or anything else that you might use. A 50 amp cord is going to provide two different legs of 110 volts for a total. They combine them to be 240 volts. So it's 120 volt. The point being that you have two different lines coming into it to create a 50 amp plug. There's two live lines coming in, one ground and one neutral. You can adapt that down to a 30 amp plug if that's all that the RV park has. That's all you can plug into. You can do that, but just remember that you only have 30 amps worth of power to use. You can run most of your things, but you're not going to be able to run both air conditioners and the microwave, when you've already got your refrigerator running, the ice maker running, those things. So the 30 amp, you just have one of the two legs coming in, and it's 30 amps worth of power. So the 50 amp, if you look at it like having two 30 amp cords plugged in at the same time, you can run anything. Unplug one of those, you only have half of your power coming in. The other thing that you can use is the generator. The generator produces power as well, and a lot of times if it's an onboard generator, it's going to produce equivalent to what you need inside your rig, meaning it's going to work just like plugging in a 50 amp cord would do. If you're using our aftermarket or any other type of generator out there, you're limited to what that generator can produce. Everything goes, once you're plugged in, everything runs through a transfer switch. You won't have to fool with this much, but if you plug in and you're not getting power, that's the first thing you need to look at, because the transfer switch just automatically will take the power from the cord and it will use it primarily over everything else. If your generator is running and you are plugged in at the same time, that transfer switch is only going to be using the power off of the stuff that's plugged in, because if you're producing power on your generator, it could also backfeed out into the power lines and kill somebody that's working on the power pole half a mile down the road. So that's the reason the transfer switch exists, is to keep power from being backfed into any system. Once your source of power leaves the transfer switch, it goes into the breaker box. Now the breaker box is what you're used to having at home. It feeds right from the power company and into every breaker that you have. As you see here, there's a main breaker, and there are several breakers off of that that are using the power, where the main breaker controls power coming in and out. You can turn the power completely off on that main breaker. Once the power leaves the breaker box, it goes into your switches, your outlets, your microwave that's hardwired in. Anything that is using 120 volt power comes right out of that breaker box. Your outlets, just like you have at home, you've got regular standard outlets. But if you see here, a lot of those are protected by GFCI. GFCI is just a ground fault circuit interrupter, meaning that it checks to make sure there's nothing wet. If you have a ground electricity leaving for whatever reason, shorting out, it will trip immediately to make sure that nobody gets hurt. Now, in the RVs, I have seen that if you move your slide in and out wrong, or as you're turning your power off of your generator and back onto your inverter or anything like that, sometimes that will trip the GFCIs. So if you're having a routine problem, check those first. Make sure that they need to be reset. If they do need to be reset, you should be fine after you've pushed the button in. As long as it's not like tripping constantly, it's not an issue. But that 120 volts also, it controls your microwave. A microwave takes, the standard one is 1100 watts. That is a lot of power, a power hog. Same with any kind of electric heaters or hair dryers. Not that I would know anything about hair dryers. If you're blowing breakers, that might be a place to look as well. That, okay, I'm overloading this circuit. What else can I do? Can I separate some things? Can I put my hair dryer on this one and the microwave on this one? What can I do to separate the power usage so that the wires don't get too hot? Now, the refrigerator is a separate little booker that it takes everything. It runs on 120 volts. That's what the standard compressor is. If you say it says, or see that it says AC on it, it's using 120 volts, but at the same time, it is using 12 volts out of the 12 volt system. That's the one place that everything converges, is in the refrigerator. There's a board on there that is controlled. The one that does the switching is controlled by 12 volts. So it tells the power to be used or not to be used. Use the power, use the gas, whatever it is that it needs to be doing. That's where it's coming from, is that 12 volt panel. That takes us over to the 12 volt side. You can assume that if, the generator will give you 75% of your power, inverter and the 12 volt system is only going to give you about 50% of the power, because you are taking a tank of power or a bucket of power and you are using it. That's all it is to store power. That's all the battery does. And you're running, if you're using the inverter to run your 120 volt appliances, you can imagine that you will go quickly through that 12 volt bucket of power, and you're not producing any more unless you have solar or something like that. But the solar is a little bit more advanced, and then you can also run your generator to refill those buckets of power. But that would be back into the 120 volt and into the generator power, because you also can run everything while you're running the generator and charge your batteries. Now, the inverters are an inverter and a charger. Now, one thing that I've had issue with it just once or twice, I didn't run the generator quick enough, and because I have the lithium batteries, they shut down on low power, and then my inverter can't start back up on just 120. It has to have 12 volts to start back up. So basically, you can jump it right here, put a positive lead to a 12 volt source and a negative lead to a 12 volt source on these cables, and it will start up long enough for the 120 to come in and start charging the batteries, so then it can power itself. Just like on the 120 volt side, there is a fuse block here. You can see where one main power comes into it, that's feeding all the little branches. That big line goes directly to the batteries, and then all the little ones go out to the accessories. And the accessories in an RV, you're using those constantly. So that's the reason that the inverter needs to be there, the inverter chargers, to constantly keep those batteries charged, because you're using them for lights. Most of your lights in an RV run on 12 volts. There are a couple that are 120, but most of the lights are 12 volt. You can see here, this is a 12 volt switch compared to a 120 volt switch. And if you see regular outlet, that is 120 volts as well. The 12 volt systems are pretty much hardwired. Like I said, all the lights and the refrigerator can run on 12 volts itself. If you don't have any AC or any gas going to it, it can run strictly on, most of them can run strictly on 12 volts. It has a 12 volt compressor and it can refrigerate that way. Your furnace, your gas furnace, has a fan inside of it that only runs on 12 volts. If you're running your furnace at night, especially when it gets really cold out, that is running 12 volts non-stop, or while it's running, it's non-stop, and that takes a lot of power to have anything with a motor. Is going to take a lot of power. And then again, the refrigerator is always running 12 volts, even if it's plugged into a household outlet. It is still, like ours has a fan in it, that's constant 12 volt usage, and then so is the light when you open the door. That takes 12 volts as well. Okay, I'm aware that this is not covering every aspect of your electrical system in an RV. If you have any questions, put them below in the comments. I'll do my best to answer them. I'm not an expert, but I'm happy to help if I can help. If you have a specific question, maybe you're having a problem with something in your electrical system, let me know. If this is received well, if a lot of people like it, that sort of thing, then I'm going to do like maybe the next one will be over the plumbing system, and I'll show you all the different parts of the plumbing system in an RV. And I certainly appreciate everybody that has watched this, and if you've gotten this far, maybe give us a like. That will do a lot to advance us in our goals here. And I appreciate everybody watching, and I will see you next week.